Greetings, ladies and gentlemen. Thank you for joining me. Welcome to TJ's Maths and Further Maths Adventures. In today's presentation, we continue with our solutions to NECO 2024, and this is Further Mathematics, Paper 2, Part A. With us here is question 5. In my previous videos, I've solved question 1 to 4. Come with me as we solve this problem together. Question 5 reads, a uniform plank AB of length 100 cm and weight 45 Newton rests on a support 35 cm from one end A. At a weight 35 Newton is suspended. We are asked to determine the weight that will attach to B to keep the plank in equilibrium. First thing to do is to identify this question is from which topic. This is from moment about a point. Well, then we have to recall the laws of that moment. Sum of clockwise moment must be equals to sum of anticlockwise moment. Okay, so come with me as we solve this together. First thing to do is to write down the solution. So let's write down the solution and we need to draw. Okay, let's say we have the plank is like this, while we have A and B, and the length of this plank is 100 cm, and the weight of this plank is 45 Newton. That's the weight. The weight of this plank is 45 Newton. The length is 100 cm. Okay, we are told that rest on a support 35 cm from one end A. So let's say we have a support here that is 35 cm. Let's say 35 cm from this 35 cm, that's from one end of A. Okay, so at a weight 35 Newton. So we have a weight here. The weight that is at this point is 35 Newton. The weight of this A is 35 Newton. Okay, is suspended. Then we are asked to determine the weight that will attach. What will be the weight that will be attached to this B such that the plank can be in equilibrium? So we don't know the weight. Let it be Fn. Okay, so from this center to point B is 50 cm because the plank is 100 cm and this is the center here. Okay, so from this point A to the center is 50 cm. So if we have taken away 35, it means from here to here will be 15 cm respectively. Okay, let's say we are taking moment at this pivot here. So let's move here. Taking moments at point C now from the drawing. If we are to take moment from this pivot, you have to understand that moment is nothing but the product of the what? Perpendicular distance and that of the force. So it means moment is force times the perpendicular distance. That's the formula for moment. So taking moment at C, we'll have, if we are to take moment at this point, there are forces that will be acting in clockwise direction as well as anti-clockwise direction. Of course, this force will act in clockwise direction, this force will act in clockwise direction, and this force will act in anti-clockwise direction as well. Okay, so if you are to take the moment at this point, it means sum of clockwise now will be equals to sum of anti-clockwise. Okay, let's look at our clockwise now. So it will be this force now, which is F times the perpendicular distance from where we are taking the moment now. So the perpendicular distance will be, we have to add the distance from this point to that pivot. So it will be 50 plus 15, which will be 65, because from this is the distance now. So which will be 65 plus another force again is 45 that is acting in clockwise direction, and from the pivot that force is 15, so it will be 45 times what? 15 plus 45 times 15. So this will be the forces that are acting in clockwise direction. This will be equals to the anti-clockwise now, which will be 35 times the distance from the pivot where we are taking the moment now, which is 35. So that will be 35 times 35. So we can easily find F. So let's use our calculator to get that. So we can say first times 65, that will be 65 F plus, we can now say 45 times 15, that will be 675. This will be equals to 35 times 35. 35 times 35 is 1225. So we can easily find F now. So 65 F will be equals to 1225 minus 675. Okay? So this will be 65 F now will be equals to, we minus 675 from 125 minus 675, we'll be left with 550. So we can divide both sides by 65, divide both sides by 65 to find the force F now. This will be equals to 550 divided by 65. 550 divided by 65 will have 8.46 Newton. This will be the force that will be attached to this point B, is 8.46 Newton. So this is the solution to this problem. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to my YouTube channel for more interesting videos. In my previous video, as I said, I've solved 1 to 4. So in my next video, I'll solve question 6, 7, 8 to 15. Thank you for watching. Please, you can share this to anyone around you.